once again, that are not doing homework. Okay, so in solving a radical equation, so this isn't simplifying anymore. Now we have an equal sign. We're solving for x that will make this a true statement if we plug it in. So these are the steps we take. First, we isolate the radical, meaning get the radical completely by itself, piece by piece. So then after that, so like let's do our first step in this example here. So get the radical on one side of the equation basically. So don't we need to add 5 over? So then we would have this, root 2x minus 3 equals 5. So that's our first step. Then second, so nothing can be even multiplied. Like if there was a 2 in front of the radical here, we'd have to divide by 2. Nothing can be added, subtracted, multiplied, or divided to our radical. And now that the radical is all by itself, we can undo the radical with the correct inverse. What undoes a square? A square root. So what undoes a square root? A square. Good. So we'll square both sides of the equation. So now look, root cancels out with power, leaving me with 2x minus 3 equals 5 squared is 25, isn't it? So then from there it just says solve for x using algebra. So now you just get x alone. So we add 3, so we have 2x equals 28. Then divide by 2. So then x equals 14. So there's our solution. And then fourth, we do need to check our answers because once we get to these harder ones, these really easy ones, there won't be extraneous solutions. But once we get to these harder ones, there could be possible solutions that we need to throw out. So if we plug in, you go like this, go back and plug it into the originals. We do the square root of 2 times 14, right? Everyone, 2 times 14 is 28. 28 minus 3 is 25. So we have root 25 under here minus 5. And that needs to equal 0. So then we have 5 minus 5 equals 0. So on the test, we can know we got it right. Because when we plug it back in, we get a true statement. So those are your steps every time. You can just watch, because you'll get some practice in here in a second. So the first step is to isolate the radicals. So we'd add 2. So we'd have root 4x plus 1 equals 3, correct? Then we'd square both sides. Root cancels out with power, so we have 4x plus 1 equals 9. Subtract 1, so 4x equals 8. Divide by 4, so x equals 2. Was that too fast, or is it like this is such easy stuff that is good enough for us? And then we'd plug 2 back in, so we'd have the square root of 4 times 2 is 8, plus 1, so we have the square root of 9, minus 2 needs to equal 1. 3 minus 2 needs to equal 1, 1 equals 1 is true, so we have done it right. Okay, now watch, there's something interesting happens here. This is going to be something we need to keep in mind as when we're solving. Now just a reminder, if we take the square root of 9, don't we get 3, for example? If we take the square root of negative 9, don't we get 3i? We don't get a negative, right? Can we ever plug anything in and get a negative? No. Okay, so let's keep that in mind as we go to solve. So let's subtract 7, isolate the radical. So we have the square root of 5x minus 1 equals negative 2. When will the square root ever equal a negative 2? It won't. It can't. It's not possible. No matter what I put under here, we can't get out a negative 2. So this one would be no solution. Now if you get that far, and you remember that rule, you're going to be good to go. You're going to be like, okay, no solution because the square root can't equal a negative. Now what if I change it to a cube root? Can a cube root be a negative? Yeah, so we wouldn't do this with a cube root. Now let's say you forgot that you can't have a negative. What would happen is you'd square both sides. So then root would have canceled out with power, so we'd have this. 5x minus 1 equals 4, because a negative 2 squared is positive 4, right? Everyone? So then from there you'd solve. So you would add 1, so you'd have 5x equals 5. So then you get x equals 1. Now this would have ended up being an extraneous solution when you plug it back in. So watch. If I plug it back in, we'd have the square root of 5 times 1 is 5. 5 minus 1 is 4. So we have the square root of 4 plus 7. Does that equal 5? 2 plus 7 equals 5? No. So that, do you see how either way we get no solution as long as we check it? Okay? So, but also it's just kind of nice to remember the rule. We can't have a negative under our square root because then we don't do all this extra work. But it would have come out extraneous if you remember to check it anyways. Okay, let's do another one. This is where it starts to get a little bit more advanced. Just a little bit more to it. So, isolate the radical. This one, the radical's isolated. Now, how do we undo a square root? Square. So we got to square this side, and this has 2 terms, so we got to put parentheses and square this side. So now on this side, root cancels out with power, and we get x plus 5 equals. Now, would it be appropriate to square that, square that? No. So we have x minus 1 squared. Well, there's no way to solve this without multiplying it out. So we actually have x minus 1 times x minus 1. So now we have x plus 5 is equal to x squared minus x plus 1. So we have x plus 5 is equal to x squared minus 2x plus 1. Don't we have a quadratic? How do we solve quadratics? We have to get it set equal to 0, correct? And then we solve by factoring. So we have a quadratic now. So here we go. Subtract x, subtract 5. Subtract x, subtract 5. So we have 0 is equal to x squared minus 3x minus 4. So now you'd say, okay, I solve quadratics by factoring. Well, multiplies to be negative 4 and adds up to be negative 3. 1 times 4, negative 4. That's our factors. So we can quick factor. Notice in this one we can quick factor because our leading coefficient's 1. So we have an x plus 1. We have an x minus 4. So now our solutions are x equals negative 1, right? And x equals 4. We have two solutions as far as we can tell, but we got to check to see if either of them are extraneous. So let's go back up. It's really important when you get a quadratic to check for extraneous solutions. So watch, I'm going to go check right here on the side here. Let's plug in negative 1. So we have the square root of negative 1 plus 5. Does that equal negative 1 minus 1? Isn't that the square root of 4 equals negative 2? The square root of 4 is what? Does 2 equal negative 2? No. So negative 1 is an extraneous solution. We've got to cross it out. Let's plug in 4. The square root of 9, because 4 plus 5 is 9, needs to equal, and it was 4. So 4 minus 1 is 3. 3 equals 3 does work. So this one's good. So our only solution turns out is 4. We got to check for extraneous solutions. Yes. It's a solution that you get, but you have to throw it out in the end because when you check it, it doesn't work. We check negative 1, it doesn't work, so we throw it out. It's not really a solution. It looked like it was going to be a solution, but when we plug it back in, it's not. Okay, so just a couple more examples and then we'll be good. So now let's go for this one. Isolate the radical. So we'd add 1. So we have the cube root of 3x plus 2 equals 2. How do you undo a square root a square? How do you undo a cube root a cube? So we'll cube both sides. The root cancels out with power. 3x plus 2 equals 8. So now just solve for x. It's just linear. So this one's an easy one. We have 3x is equal to 6 because I subtracted 2. So then x equals 2. And then we can check it. The cube root of 3 times 2 is 6 plus 2 is 8. 8 minus 1 equals 1. So cube root of 8 minus 1 equals 1. So then we'd have 2 minus 1 equals 1. 1 equals 1, yes. So we've done it right. Okay, so I think we, for the most part, get the picture here. But what would we do first? Add 8. So then we have 2 cube root of 6x plus 3 equals 6. Am I right? Now from here, a lot of people have this inclination to then cube both sides. You can't do that yet. We have a 2 in front. We got to get rid of the 2. You got to isolate the radicals. We divide by 2 very first. Way important. So then you have the cube root of 6x plus 3 equals 3. So now we cube both sides. So we'd have 6x plus 3 equals cube. Cube both sides. Root cancels out with power. So then we have 3 times 3 is 9. Times 3 is 27. So then we'd subtract 3. So we have 6x equals 27, 26, 25, 24. Then divide by 6. So x is equal to 4, and then we would check our solution. Okay? Pretty easy stuff. Let's get to some of the more advanced ones. That's why I'm going so fast through these ones. So now what if we have something written as a rational exponent? Aren't rational exponents actually radicals? Same thing, right? Fractional exponents, remember, isn't the square root of x the same thing as x to the 1/2, and vice versa? So if you look at this, we actually just have a radical right here. Look, 1/2. That's a square root function. So you do the same thing. You'd say, I need to isolate the radical. We know that's actually a radical, so isolate that part. Does everybody see what I'm saying? So we'd subtract 3. Now all this stuff is obviously raised to the 1/2, so that's all trapped under our radical. So we have 5x minus 1 raised to the 1/2 is equal to 7. Is everyone okay? Now from here, what undoes a square root? Isn't this a square root? Yes? a square, right? Now look, it makes sense. Look, mathematically, look why it makes sense. If I raise both sides to the second power, look, raise a power to a power and you multiply it. A half times 2 is 2 over 2, everybody, which is 1. So do you see how that takes care of our radical? So that makes sense. So we actually just raised it to what's called the reciprocal, because that's 2 over 1. Reciprocal means just flip it. So we have this, 5x minus 1 to the first is equal to 49. Well, anything to the first is just itself. So we actually just have 5x minus 1 equals 49. So then we'll add 1, so we have 5x equals 50. So then x must equal 10. And then we would check our solution again, plugging it back in to here. So then you would, when you plug this one back in to check it, you would have the square root of 50, the square root. You see why I'm writing it as a square root? Because we really should be just being able to calculate it by hand for the most part. So 50 minus 1 is 49. So we have the square root of 49 plus 3, that needs to equal 10. So that's 7 plus 3 equals 10. So 10 equals 10 is true. Okay, let's do some more in here. So, isolate the radical. Which part is the radical? 2x minus 3 is raised to the 1/3. Cube root. Roots are on bottom. Cube root, notice, so we'd add 7. So then we'd have our 2x minus 3, and then is equal to, to the 1/3 is equal to, add 7, you get 3. Now from here, how do you undo a 1/3? Yeah, raise it to the third. Yes, cube both sides. You're right. So we need a cube and cube. So then look, this becomes a 1, which is what we need. So we have 2x minus 3 is equal to 3 times 3 times 3 is 27. So then we have 2x is equal to, you add 3, and we get 30. So then x equals 15. And then we could check our solution again. Okay. So now, don't let this throw you off. This example here, I wanted to do, I guess actually, I was thinking they were going to do some a little bit harder than that. Like, what if this would have been raised to this? The 2/3 power. You times it, but you'd raise both sides to the 3/2 power, everybody, right? So instead of just 3, it would have been 3/2. So if this would have been a 2, it would have been 3/2. So now look, this would become a 1, because look, 6 over 6 is 1. So you just raise it to the reciprocal. So now right here you'd say this is the square root of 3 cubed. Does everybody see how to do it? Or 3 cubed is 27, right? And then take the square root of that. This one I just made up on the spot, so it didn't come out very pretty, but it would on the whole number. It'd come out like a whole number. Okay, so what would we do with this one? Isolate the radical. Well, here's a radical and here's a radical. If you have 2 radicals, you always want one on one side and one on the other side always. So, done. Then how do you undo a cube root? Cube both sides. Well, look how nice this one ends up being. Root cancels out with power. So we have p squared minus 4p minus 4 is equal to, root cancels out with power, and we have negative 3p plus 2. That one worked out nicely. But then you would say to yourself, I have a quadratic. To solve a quadratic, I need to get it set equal to 0. So add 3p, subtract 2. Add 3p, subtract 2. So that would be p squared minus p minus 6 equals 0. Then you factor it. Well, multiplies to be negative 6 and adds up to be negative 1. That's 3 times 2, negative 3. So that factors to be p minus 3 and p plus 2. So p equals 3 and p equals negative 2. Whenever you have a quadratic especially, you need to check both of your solutions. So we plug in this one, we'd see if it works. If we plug in negative 2, we'd see if it works. They actually both end up working in this one. Do you want me to go through it, or do you feel like you would be comfortable checking your answers on your own? Just see if it's a true statement when you plug it in. Okay. Awesome. Okay, so now this is when it gets a little bit more advanced, everybody. Write this example down for yourself. So we have the square root of 3x plus 6 minus the square root of x plus 6 is equal to 2. Now notice these are not like radicals, so we can't actually add them together. And notice we have 2 radicals. Once again, if you have 2 radicals, you always want one on one side and one of the radicals on the other side. It's going to make our math come out a lot nicer, even though this one's still going to be pretty advanced. So get one radical to the other side. So I'm going to add the square root of x plus 6 to both sides, add root x plus 6. So now on this side, I'd rewrite it. You have the square root of 3x plus 6. And over here, be careful because we actually have 2 plus the square root of x plus 6. Now what you're going to do is you're going to say, okay, to undo, so look, to undo a radical, don't we need to undo a square root? Don't we square both sides? Yeah? So we got to square this side. Now there's 2 terms here. This has to have parentheses, and we got to square this side. So now over on the left it actually is really pretty. Root cancels out with power all nicely. And we have 3x plus 6 is equal to. Now over here we're not going to do something like break the forbidden rule and think that we can just square that. We can't do that across addition signs. So when we have something squared, don't we have to write it out timesing itself twice? So this one we have no other choice to do 2 plus root x plus 6 times 2 plus root x plus 6. Now we just learned in the last lesson how to multiply out radicals, so it's actually not that bad. So let's go through and see if we can solve this one here. So now we have this, 3x plus 6 is equal to, let's distribute this out. 2 times 2 is 4. 2 times that is plus 2 root x plus 6. Now I've multiplied 2 out. This times this is plus 2 root x plus 6. Then we have this times this. Now this is where a lot of people have a hard time, but be really careful here. So it's actually plus, isn't there both square roots, right? Let me scroll up for the people in the back. We have a square root and a square root, so they're under the same square root. So we have the square root of, and then don't we have 2x plus 6's? X plus 6 times x plus 6, everyone. So we actually have this, x plus 6 squared, don't we? Okay, so now simplify this side more. So we have a 4 plus 2 root x plus 6's plus 2 root x plus 6's is how many root x plus 6's? 4 root x plus 6's. Then over here, doesn't root cancel out with power? Square roots cancel out with squares. So then we have a plus sign, and then we have x plus 6. So now you can continue simplifying that side. Combine like terms. If you'll notice, we have a 4, we have a 6. That's a 10. So we have 10, then we have plus x, then we have plus 4 root x plus 6. So I've just combined all like terms on this side. And now we can't forget about, we also have 3x plus 6 is actually equal to that. Now we're not even done yet, because what do we have? A radical. How do we solve radicals? We isolate the radical. So then you'd say, okay, I got to take care of this final radical here. I got to get that all by itself. So subtract 10, subtract x. Subtract 10, subtract x. So then we have 2x minus 4. 2x minus 4 is equal to 4 root x plus 6. Now guess what a lot of people are going to have the want to do, because this is what we've done for all other problems. You're going to want to divide by 4 to get the radical by itself. But now let's think about why in this problem we might not want to divide by 4. We have to be careful because we're not going to do that. We got to be careful when doing our algebra. Now here's why. If I divide by 4, that would not be wrong. But then after that, wouldn't I square both sides? And now I'm squaring a fraction. It wouldn't be wrong, but it'd be harder. Can I just square it like both sides here, as long as I square that too? The 4 as well? Yes, so watch. You'd say, okay, I don't want to deal with squaring fractions, because if I divide by 4, I'll have fractions. So instead, I'm just going to leave it, and I'm going to square both sides, but I'm going to remember, I can't forget to also square that. As long as I don't forget to square that, I'm okay mathematically. So we have over here, we wouldn't break a forbidden rule, so we actually have over here 2x minus 4 times 2x minus 4. And on this side we have equals, we got to square both of them. So 4 squared is 16, isn't it? And then it's a times sign, so we have a times sign, parentheses. And then isn't a root and a square going to cancel out? So then left would be 16 times x plus 6. problem's a long one, but we can do hard things in here. So we're almost there. Now, finally. So now we gotta say, okay, well, how are we gonna solve this? We need to have all like terms in the same spot. So we gotta multiply this out. 2x times 2x is 4x squared. 2x times negative 4 is negative 8x. Negative 4 times 2x is negative 8x. And then negative 4 times negative 4 is plus 16. Then over here we have 16x plus 16x plus 10 times, I gotta do it in sections if I'm gonna do this. Oh, that's 16x too. So that'd be 60, and then, yeah, plus, yeah, 36, that'd be 96. So now look, we have a quadratic. Don't we need to have it equal to 0 and combine all like terms? Yes, okay, so we have this. 4x squared, I'll hurry and combine these, minus 16x plus 16 equals 16x plus 96. So now we're going to subtract 16x. This problem is a long one. Look at this. Let's see here. Let's see how long we've gone so far. Pretty long. We're almost there though. Subtract 16x, subtract 96. Subtract 16x, subtract 96. So now we have 4x squared minus 32 x's, and then minus 80 equals 0. Now everyone, right now I can't quick factor because of that 4 in front, but couldn't I factor out a 4? Let's do that so we can quick factor. So let's pull out a 4. So divide by 4, divide by 4, divide by 4. So then left would be x squared, right? Minus 8x, and then minus 20, equals 0. Now, when solving, and you have a 4 in front, is it going to affect your solutions? No. Can I just divide both sides by 4 and get rid of it? For solving, yes. Right? For solving, factoring, no, it's got to be there, but we're solving, so that's not going to matter. So now we do what multiplies to be negative 20 and adds up to be negative 8. 1 times 20, 2 times 10, 4 times 5. 2 and 10 is it. Yep, so it would be negative 10 times 2. It quick factors, so we have an x plus 2 and an x minus 10. So x equals negative 2 and x equals 10. And then after all that pain and suffering, we got to go check our answers. So what did we do, guys? We first got one radical on one side of the equation. One radical on one side, one radical on the other side. Then we squared both sides, and it just came out to be a big, nasty multiplication problem. Now, in the end, we then still had a radical, so then we isolated that radical, getting it by itself, and then we undid it again. We undid the radical again, and then finally it did get rid of all radicals. And then it just came out to be a quadratic that could solve by factoring. So just a reminder of what we did. So then we'd go check them. We had negative 2 and 10. So we could check them both. I'm seeing that both are going to end up working. Do you want me to go through checking it, or do you think it's going to be okay by yourself? Okay, awesome. Alrighty then. Okay, we don't need to do another one of that caliber. You'd be able to do it by yourself. Okay, just making sure. Alright, this is my last example, okay? If I said to you solve for L, we would not freak out. This is easier than anything we just did. Solve for L. It's called a literal equation. Solve for the variable L. So that means get L alone. So what would we do first, maybe? Yeah, divide both sides by 2 pi, because that's multiplied. Divide by 2 pi, I agree. So now you'd have t over 2 pi is equal to the square root, so you're isolating the radical. Who said that? Who was the person that said divide by 2 pi? Oh, okay, good job, yeah. So you're isolating the radical, right? So you guys see how she's still saying the same steps in her head. She's saying, okay, we got to get the radical by itself. Yeah? Okay, so then we have over here, L over 32. Now what would we do? Square both sides, yeah? Everyone? Okay, so we'd square both sides. Square, square. So then we have t over 2 pi, all squared, is equal to L over 32. And then what would we do? Last step. times by 32. Now you'd say, is L alone? Yes. So all is good. Now because we don't know what t is, we're not going to have to solve anymore. Like we're good. Right here is good to go. Okay, cool. Okay, go work on 7.7 for a minute. Go practice some evens or odds. Then once again, you guys know the drill. Same drill.